Good afternoon, class. We are looking at final exam review for Calculus 1, covering sections 2.1 all the way to 6.1. Here's the last part, integrals, areas between curves. I want to emphasize again, before starting the exam, please read the following pledge. This is what you find on your exam. I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. Meaning, you take the exam on your own. Assume you're in class when you take the exam. All right, let's go over a few more questions today. Given this is a definite integration, which means a number. The integral of 1 to 3 f of x dx is given as 6. From 3 to 7 is 9. From 1 to 3 is -4. We want to find the following, starting with 1 to 3. 3 times f of x dx. Obviously, we take the 3 out. This one is 6, so 3 times 6 is 18. The integral of 1 to 3, 2f of x minus 4 times g of x dx, and we separate them into two integrals. This one we take the 2 out, this one we take the -4 out. So this one, we replace it with 6. This one, we replace it with -4. 2 times 6, 12, plus 16 is 28. 1 to 7, the integral of 1 to 7 f of x dx. What happens in this case is we have 1 to 3 and 3 to 7. From 1 to 3, the integral is 6. From 3 to 7 is 9. They add up to 15. These are various properties that we are using. And the integral of 3 to 1 f of x dx, we go back to this. Because we are interchanging the limits, we put a negative sign in front. So the integral of 3 to 1 is negative of integral of 1 to 3, which is the same number. Negate that, and that's your final answer, everybody. We want to evaluate this integral, which means we have two parts to discuss. Because we're going to go from -2 to 2, we're going to cut this into two parts. From -2 to 0, 0 to 2. And by the way, if by any chance this was from -infinity to 0, and this was from 0 to infinity, it would work out the same way. Just wanted to let you know. So you're going to integrate this. You get 2x from -2 to 0, and this one is 4x minus 1/3 x cubed from 0 to 2. The rest is elementary algebra. You're going to plug in. So let's plug in. In this case, 0 goes first, -2 second. In this case, 2 goes first, and 0 doesn't. So this becomes 0. And so, of course, this is 4, this is 8, this is 12, this is 8 divided by 3, 8/3, so -8/3. So this is 0. And the answer is 28/3. ddx of the integral of 1 to x squared plus x tan t dt. And again, reminding you of some theorems. This is, of course, the definite integral of f of x dx is f of b minus f of a from a to b. If you take the derivative, this is one of those FTCs, fundamental theorem of calculus. Then the derivative of the integral gives you the function back at the upper limit. Okay. And if it's not x, if it's g of x, then you evaluate f of g of x and then times g prime of x. This part is by the chain rule. So first and foremost, notice this is t, therefore we are looking at f of t in essence equals tan t. So we are going to replace it according to this. We are going to replace the t with the upper limit, which is x squared plus x. And then g prime of x. This is your g of x, by the way. Okay, let's just, so this is g of x. And so you are going to differentiate that, gives you 2x plus 1. We multiply by it, and we're going to put that in front as the final answer. Now, ddx of the integral of t squared dt as we go from tan x to sine x. Now, what happens here? The lower limit is a number, any number. A represents a number, any number, this is the answer. But what happens if the bottom is also a function? In that case, first of all, f of t is t squared. Secondly, now ddx of the integral of g of x to h of x f of t dt is if you put the upper limit in times h prime of x, just like this one. Then minus, you put the lower limit in times g prime of x. So in that case, so f of t is t squared. So replace the t with sine first. So you get sine squared x. And then by the chain rule, we multiply by the derivative of sine, which is cosine x, minus, now we go back to the same function, and now we put the lower limit. So tan x squared, so minus tan squared x. And by the chain rule, the derivative of tan x, we multiply by it, which is secant squared. So we are using this one. What about this case? Notice the function f of t is this piece, and the lower limit is a function, the upper limit is a number. So we do two things. Number one, notice this is the function. Number two, we're going to interchange these two and we put a negative in front. Again, that was one of the theorems that have been discussed. So minus, because we are putting the 1 as lower limit and sine x as upper limit, and now we're going to follow that. So this negative remains. F of g of x, that means over here, replace the t with sine x, we get square root of 1 plus sine squared. The negative sign remains. So minus the square root of 1 plus sine squared x. And now you need the derivative of sine x times cosine x. And it's really a good practice to bring it to the front. Again, remember, the upper limit is a number, so you interchange those two, and then you create a negative sign as a result, and then you follow this rule. A particle moves along a line so that its velocity, v of t, is t squared minus t minus 6, measured in meters per second. Find the displacement of the particle during the time period of 1 to 4. So we are really discussing two things: displacement versus distance. So I'm going to remind you that as we go from T1 to T2, what happens, the distance is the entire thing. So if you go zigzag, the distance is covering this one, this one, this one, this one, this one. But displacement going from A to B, that's the concept. So distance is the integral of the absolute value. So you add up A1, A2, and A sub 3, but displacement, it's just the integral of v of t dt, which means these two are positive. We add them up, but this one we have to subtract. So A1 minus A2 plus A sub 3. So that's the idea. And in this case, we are talking about the displacement. So we just write the integral of v of t dt from 1 to 4, which is also known as S of 4 minus S of. And that's really the idea behind this question. So plug in. This gives you 1/3 t cubed minus 1/2 t squared minus 6t. And when you plug it in, and I'm going to leave it for you to do that, you end up with -9/2. So what does that mean? The particle moved 4.5 meters towards the left in the negative direction. In part, we want the distance. And to find the distance, you have to take the integral of the absolute value. And to take the integral of absolute value, you have to know where the function is positive, where the function is negative. And to do so, we are going to factor this into t plus 2, t minus 3. Because we want two numbers, the product is -6, the sum is -1. And you go with a number line. From negative to positive infinity is fine, although we talk about time, you can go from 0. But in any event, t in this case can be negative, and in this case can be 3. So you can do the number line on that, but we will go from 1 to 4 only. So it doesn't matter even if you put minus and positive infinity, because we know what we need is 1 to 4, everybody. All right. So remember what happens. You go with the test point, so TPs, short for test points. And so obviously the easiest point, let me use a different color, is the easiest point in between these two is 0, right? So you plug in 0 here or here, and it becomes negative, and they will alternate because each one has exponent odd. And so in this vicinity is negative, in this vicinity is positive. So in this vicinity, which means we are going to go from whatever the starting point. The starting point is whatever they have given us. From this point to 3, we use the negative of this statement because we want the absolute value, right? And then from 3 onwards, 3 up to whatever this number is, we use the actual function. So from 1 to 3 minus v of t dt, and from 3 to 4 v of t dt. And that's really the idea that you want to be careful of. The rest is not a big deal. And so, so this one is minus t squared, or if you use minus t squared plus t plus 6. The other one is itself. And so this is negative 1/3 t cubed plus 1/2 t squared plus 60. This is 1/3 t cubed minus half of t squared minus 60. This part goes from 1 to 3. This goes from 3 to 4. And I'm going to leave it for you to plug in. The precise answer is 61/6. By the way, you always answer this one, not this one, unless they ask you for so many decimals. I can't emphasize this enough. It happens all the time. And I just don't get it why calculus students make that mistake. If f of x is this, differentiate, integrate, and you name it. Okay. So I just wanted to remind you what happens with the exponentials and sinusoidal functions when you differentiate versus integration. So if I want to differentiate this, remember, exponential is itself, and then you multiply by -0.2, and sine, the derivative is cosine. So this 2 becomes a negative 0.8, and you're done. Now to integrate, I'm going to integrate it times dx. And so again, whether you differentiate or integrate exponential is itself. In the case of differentiation, you multiply by this. In the case of integration, you divide by negative 0.2. Okay. Now minus sign results in cosine, positive cosine, because the derivative of sine is cosine, but the integral of that is negative cosine. With this negative becomes positive and it comes. This is 40 over 0.2, which gives you 20. Keep the negative sign, minus 20 e to the power minus 0.2x plus cosine x, and a constant. And now as far as the initial value, if they give us one pair, for example, f of 0 equals 20. So in this case, replace the x with 0 and f of x with 20. Now, of course, e to the power of 0 is 1, cosine 0 is 1. So again, negative 19 on the left, you move it to the right, becomes positive. C is 39, and you're done. Again, general solution, particular solution. With one pair, we can get to a specific solution. Family of functions versus one of those. We want to evaluate the integral, and of course, we can do it just the way it is. But one of the things that is helpful when you are dealing with definite integrals that are numbers, and that is, if it's an even function, and you want to go from negative to positive, so for example, from negative a to a, in the case of an even function, you can go from 0 to a and multiply it by 2. In the case of a odd function, becomes 0. Look at the odd function. These two are identical in size. They cancel each other because one is positive, one is negative. Remember, the definite integral represents the difference of areas, okay? And in this case, the right and left are identical. You can go from 0 to a and multiply it by 2. In this case, we notice the function is x to the power of 6 plus 1, and f of minus x equals f of x. Okay, this is your function f of x, okay? This is f of x. It's an even function. It's easier to evaluate it from 0 to 2 and multiply it by 2. That's the idea behind this. And so this is 1 over 7x to the power of 7 plus x. And if you plug in 0, nothing happens. You plug in 2, you do the math, and you multiply it by 2, you get 284 over 7 as the final answer. The point of this question is, can you evaluate it from negative to positive 2? Absolutely. But it's a lot faster if you do it from 0 to 2 and multiply it by 2. That's the meaning of this. However, what is the meaning of this? This we can't integrate anyway. So when that happens, you're hoping that it's an odd function from minus a to a. These two numbers, it's important to know, minus a to a, minus 10 to 10, minus 2 to 2, minus 1 to 1. So negative to positive, okay? And so this is 0 because this function is an odd function. To prove it, replace the x with negative. So what is f of minus x? Tan of minus x, which becomes minus tan x. These two don't change because minus x to the power of 2 or 4 is the same thing. So f of minus x is minus f of x, which makes f of x an odd function. So it's equal to 0 because it's an odd function. You have to prove it's an odd function, everybody. All right. This expression, whether we want to differentiate or integrate, makes no difference. First, we have to do some algebraic technique. This is x to the power of 1/2. Make up two fractions. And this over this and this over this. This has exponent 1. 1 minus 1/2 is 1/2. And in this case, minus 1/2. And now you have made it ready for the power rule. So this is 1 over 1/2 plus 1. X to the power of 1/2 plus 1. This is 1 over negative 1/2 plus 1. X to the power of negative 1/2 plus 1 and a constant. 1/2 and 1. This is 3/2. This is 1/2. So the reciprocal of 3/2 is 2/3. The reciprocal of 1/2 is 2, and we are done. All right, we are integrating using this substitution. So the integral of f of g of x, g prime of x dx, where g of x is the u and g prime of x dx is the u, is integral of f of u du. Again, if you're using a u substitution, Here's the tip. Look for a function u equals g of x anywhere in the integrand and its derivative du or g prime of x multiplied by g of dx. If you don't write the u and du, you are wrong. Some students get to the next step without writing that. Unacceptable. You're dealing with polynomials. The more complicated one, in this case, x squared plus 5 is the choice of u. The derivative is 2x. So du dx is 2x, which means du is 2x dx. You have to write this first before you move on. I can't emphasize this enough. Otherwise, you're wrong, and I will take off points. I'm going to move the 2x, so it becomes clear this is u, this is du. So you have the integral of u to the power of 30 du, which is using the power rule, 1 over 31 u to the power of 31 and a constant. Reverse substitution. 1 over 31 x squared plus 5 to the power of 31 and a constant. Both cases are fractional format. After simplification, the denominator is a choice of u. Notice its derivative is e to the power of t, which makes du e to the power of t dt. Again, make sure you write u and du. Then we are going to rewrite this so it becomes clear. Dt belongs to the numerator, and you're dealing with du over u, which gives you a natural log. Replace the u, and you're done. This case is a rational function, but the methodology is the same. The first thing is I want to simplify by factoring the denominator, and I can't do so. I remind you of the quadratic formula. Everybody knows what that is. B squared minus 4ac is the discriminant. When it's positive, you have two roots. Negative, no roots. 0, 1, real solution. And if b squared minus 4ac is a perfect square, this can be factored, and I hope you recognize in this case, a is 1, b is 2, c is negative 1. So b squared minus 4ac is 2 squared minus 4 times 1 times minus 1, which is 8. This is not a perfect square, can't be factored. So use the denominator. Du dx is 2x plus 2, or 2 times x plus 1. Du is 2 times x plus 1 dx. We rewrite this. And I hope you remember, when a number is missing, it's easy. Just throw in the number, undo it with its reciprocal. And this part becomes du over u, and that's a natural log. Plug in, and you're done. What happens when you have a reciprocal of anyone? If this is the case, you just make up two fractions. If this is the case, you do long division. The point being, you don't need the substitution method. This is the same thing times divided by -1, so minus 5 e to the power minus t plus t and a constant. That's why I have those questions again next to each other, so it becomes clear. It's an easy integration. You have a natural log. That's the choice of u. So du dx is 1 over x, which makes du 1 over x dx, or dx over x. Always, it's a good practice to rewrite this. It becomes clear for you and your reader what you're doing. This is identical to this one. Now, the difference is everybody can see this is u squared and this is du. By the way, I like to write du in two different formats. So So you'll be familiar with those. Now it's 1/3 u cubed and a constant. Replace it and you're done. Any fraction, the first step, can I simplify? That's the question you're going to ask yourself. The answer is no, we can't. Notice the derivative of the bottom is the top. So if u is the bottom, the top times dx is du. Again, that's your first step. Again, let me emphasize this. You put the dx at top. Please don't go from here to here. You can't without writing this and justifying your doing so. Okay? Many students do that. Go from here to here. Unacceptable. What's in your head, put it on your paper. Natural log, plug in, and you're done. Those who go from here to here, they will lose somewhere between 2 to 4 points without justifying. Notice your independent variable is theta, so 5 gives you 5 theta. Cosine gives you positive sine, so 2 sine theta and a constant. Anytime you have exponential, the exponent is the choice of you. The derivative is 5x to the power of 4, which makes the u 5x to the power of 4 dx. Move x to the power of 4 next to dx. Again, this is a good practice. Here's the reason. You go back to your own notes years from now, you know exactly what you've done. So everything is in order. 5 is missing, so you can put the 5 and undo it with its reciprocal. You can do that with numbers and numbers only. So this is e to the power of u, this is du. And the answer is 1/5 e to the power of u and a constant. Replace it. 1/5 e to the power of x to the power of 5 minus 2 plus a constant. Natural log is involved. That's a choice of you. You know the derivative is 1 over x plus 1 times the derivative of the argument 1. So 1 over x plus 1, which makes du 1 over x plus 1 dx. Put the dx at top or put the x plus 1 under dx. Either way is fine. So you can see that you're dealing with u du, and what are the limits? You can't use the original limits. So if I put 0 here, I get ln1, which is again 0. If I put 1 here, I get ln2. And now, of course, I put ln2. 0 gives me 0. Again, bear in mind, this is the exact answer, class. You keep it as exact, okay? The integral of dt over cosine squared times 1 plus tan t. There are a couple of different ways. Either way is fine. I can bring the cosine squared up and call it secant squared. And the denominator is u. Well, the derivative of 1 is 0. Tangent is secant squared. So du dt is secant squared, which makes du secant squared t dt. You must write this. You get the integral of du over u, which is a natural log and a constant. Replace it, and you're done. Sinusoidal functions. When the argument has an exponent, the argument is a choice of you. Its derivative is 2x, which means du is 2x dx. This is important. Put the x next to this. Everything is in order. Number 2 is missing. It's a number. Plug in 2 and undo it with 1/2. Sine, the derivative is cosine, the integral is negative. So negative 1/2 cosine u and a constant. U is replaced with x squared. We are done. But what is the difference between these two? This one has just one of it. This one has both sine as well as cosine. In which case, the one that has the exponent is a choice of u without the exponent. That makes it sine. The derivative is cosine. That means du is cosine x dx. So you're dealing with u squared du. Again, I'm going to emphasize again. This may be in your head. That's not good enough. You have to put it in your paper. 1/3 u cubed, replace it, and you're done. What happens here? Cosine as the exponent. That is the choice of u. The derivative is negative sine, which makes du negative sine x dx. So now, over here, sine x dx is missing a negative sign. You can throw a negative sign in, negative sign out, because the reciprocal of -1 is -1. So you're looking at negative integral of u to the power of 20 du, which is -1/21 u to the power of 21 and a constant. Replace it, you're done. Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30, this equation predicts the growth rate, pay attention to rate, is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years and rounding? Well, if we let L of x represent the length of the fish at any age x, then its rate, which means L prime or dl dx is this one, and this is the initial value. So according to the, this is also known as accumulated change. So the amount of increase over the course of 4 years, there is this integral from 0 to 4, of course, with this function. And so you divide by negative, you get negative 29 e to the power minus x from 0 to 4. You have to plug in. It doesn't matter. This is 1, and it becomes 28 at a point, and I put a bunch of decimals. And that's the amount of increase. Initial value was 1. They add up. And now I pay attention to 1 decimal. Since I want 4 next to this 6, I take it up to 5. So it's a good practice to follow the instruction. And by the way, the reason they're asking for rounding, because this is an approximation itself. Now, the second method is to actually find L of x, which means to integrate this. You already have this answer plus a constant with an initial value of L of 0 equals 1. Remember, this is a general solution. So if I replace x with 0, L of x with 1, this is -29 plus what number is 1 is 30. So C becomes 30. This is the function. And since we want it after 4 years, replace the x with 4. And again, the advantage of this is that if they want it after 5 years, 10 years, 20 years, you can go with that route, okay? Find the absolute max and mean value for this function in the given interval, and we are going to use what's called the extreme value closed interval theorem. So first, what type of function do we have? We have a polynomial function of degree 4, everybody. That's important to understand. The domain is all real numbers, which makes it continuous everywhere, from negative to positive infinity. Therefore, it's continuous in the given interval of -4 to 1. Now we follow the methodology. We want to find CPs. We need to find F prime. So F prime is 4x cubed minus 36x. Because we want to set it equal to 0, we start factoring. We factor the 4x. We factor x squared minus 9. We set it equal to 0. That gives us 0, -3, +3. Also, you want to look at F prime does not exist. F prime itself is a polynomial of degree 3, doesn't produce any solutions. Where it doesn't exist, it exists everywhere. So there are three solutions. We go back here. 0 is in between. Yes. -3. Yes. What about +3? No, +3 is outside. It's larger than 1. So that one is out. So -3 and 0 belong to this given interval. So let's evaluate the original function at the two endpoints as well as the two critical points. That's the second step. So we use the function. We plug in -4. So -4 to the power of 4 minus 18 times -4 squared gives us -32. We plug in -3. We get -81. 0 gives you 0. I hope you recognize that quickly. And 1 gives you 1 minus 18 or minus 70. So those are easy calculations. Now, absolute max. So the last step is the largest value. And all of them are negative except 0. So that's the absolute max at 0, 0. And this is the absolute mean at -3, -81, and get that. We're going to evaluate the integral, and the idea is that reminding you how a definite integral is evaluated, especially if you need substitution. All right. So first, with the substitution, the more complicated one is 25 minus x squared. That's a choice of you. Its derivative is -2x, which makes du -2x dx. Move the x, -2, missing. Put the -2, undo it with -1/2. So what we are looking at is -1/2 the integral of whatever the limits are, square root of u du. We're going to work on this, and then we take it from there. So this is -1/2. This is u to the power of 1/2. And this one is 1 over 1/2 plus 1 u to the power of 1/2 plus 1. And so this one is three halves, making this one the reciprocal 2/3 times -1/2 is -1/3. You can go back to the original function, original limits. Or you can use the new limits. What are the new limits? If you plug in 3, when you square it, you get 9. 25 minus 9 is 16. We can put 4, square it is 16. 25 minus 16 is 9. So you can go with that and plug in. Evaluate it. We've done this a number of times. By now, you know that. 3 cubed is 27. 4 is 64. Their difference is negative 37 with negative 1/3. That's the final answer. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek as seen in the diagram. Find the maximum. Okay, if this diagram is not given, you have to figure it out. You can't do without a diagram. You can't do without defining your variables. X is the width, Y is the length, A represents the area. You want to maximize the area, which is X times Y. The constraint is you need 240 feet of fencing, 1, 2, 3x plus 1y. This doesn't need it, was 240. The methodology is to solve for y in the constraint, put it into a, and now a, which has two variables, becomes a function of 1. Now x must be between 0 and 80. Y should be larger than 0 because it represents dimensions. Y is less than 80. If you set this one equal to 0, x becomes 80. And larger than 80 makes this expression negative, makes the area negative. A prime 240 minus 6x. When you set it equal to 0, the critical point is x equals 4. So we have an open interval with one critical point. So local becomes absolute. But is it max or mean? We go with the second derivative test. A double prime is negative 6. Remember, you have to plug it in, and this is independent of x. It doesn't matter. It's always negative. Concave down, because looks like that, it's a maximum. So maximum occurs when x is 40, plug in, find y, and maximum is 40 by 120 feet. 4,800 square feet. Again, applications cannot be done without drawing, if need be, the drawing and defining variables. A box with a square base, an open top, must have a volume of 32,000 cubic centimeters. Find the dimension that minimizes the amount of material used. So, reminding everybody of a couple of things. Number one, this is a rectangular solid. The volume, the surface area, if all sides are equal, we call them a cube. And so, in this case, the objective is to minimize the surface area. The surface area is the concept of gift wrapping. So the surface area for this one, you have to define your variables. The sides are x by x by h. Without those, this is meaningless. You can't go to your equation without saying, okay, let x represent the width, the length, because it's a square base, and h represents the height. You have to define your variable. So the surface area, the one looking at you is x by h, this face, and four sides are identical because the base is square. Then you have the bottom, which is x squared. Normally you have two of them. So we have 4xh plus 2x squared for gift wrapping. Since it's open top, just 1x squared. So you have the drawing, you have your variables. Now, yeah. So if you write this one without showing this is x, this is x, this is h, this is meaningless because your reader doesn't know what x or h represent, okay? Subject to the volume, x times h, x squared h to be 32,000. So in this case, we're going to solve for h. In this case, we're going to replace the h to make it s of x a function of one variable x. So notice 4x times h plus x squared. Now 32,004, their product is 128,000. X goes away, this becomes only x. And for the sake of the next step, which is differentiation, we're going to bring the x up, and of course, x must be positive because x represents dimension. There is no other information. X must be positive because it represents sides. So differentiation, this gives us negative 128,000 x to the power minus 2, and this gives us 2x. We are looking for critical points, so we are going to take this down. And then this becomes 2x cubed over x squared because we are taking a common denominator. A fraction is 0 if the top is 0. So 2x cubed is 128k, x cubed is 64k, x is 40, and so we have one critical point with an open interval. Is this going to maximize or minimize? Let's find out. We go with S double prime, which is the product of these two, positive 256,000, x to the power minus 3 plus 2. And the second derivative test says plug in to observe whether it's positive or not. So when we plug in, please understand this, even if you don't know the value is positive, plus 2 is even more positive. And positive means concave up means minimum because it looks like that. So minimum occurs when x is 40. So put it here. X squared is 1600, divide by it, and h becomes 20. So x is 40, h is 20, x is 40. Those are the dimensions. We are done. We just wanted the dimensions, but if somebody said, okay, what was this surface area? You can plug it into this and get 4,800 centimeters squared. Find the area of the region that is bounded by the graphs of f of x equals 2x plus 1 and g of x equals x squared plus 1. And I'm going to assume everybody knows this is a graph. You pick up a couple of pairs. X is 0, is 1. Y is 0. This is negative 1/2. And this one, y equals x squared, is a parabola, opens up, shoots up by 1 unit. So you want to graph the two functions. I'm going to assume everybody knows how to graph. The line is at top. This is 1, 0. This is negative 1/2, 0. And this is the graph of y equals x squared that has shifted up by 1 unit. So we have to find points of intersection. Even if you can get it from the graph, that's not acceptable. You have to solve. So find the points of intersection. Set f of x equals g of x. So these two are equal. To solve, we bring everything to the right, factor out the x. The answer is 0 or 2. So if I plug in 0 here, I get 1. And if I plug in 2 here, I get 5. And I highly recommend you plug it into this one. 0 gives you 1, 2 gives you 5. That shows that you haven't made a mistake. So this must be done. Now you evaluate the integral. Now, notice this is completely at top, so we can draw an increment of the area. This rectangle has this width, this length, and the width is delta x because you move this, you sweep it across the x-axis, and this one is y of the top. What color do I want? Y of the top is here, that comes from the line. Y of the bottom is here from the curve. So y of the top minus y of the bottom, f minus g. Okay. And we're going to go from 0 to 2 because we are going to sweep this across the x-axis. And so when you do that, this one 1 and 1 cancel each other. You get 2x minus x squared. This is 2 x. The integral is x squared. This is minus 1/3 x cubed from 0 to 2. You do the math, you end up with 4/3. I'm assuming this part is our elementary algebra. You plug. Why did I choose this? This is a type of function that the line is completely above, and you can use y of the top minus y of the bottom. Also, the curve is completely on the right side. So you can do it with method 2, okay, by writing them as a function of x. So remember, this is y, everybody. All right, so this is, again, x of the right minus x of the left. Okay, x of the right minus x of the left. And this green piece has to go up and down to sweep across the y-axis, then has a width of dy. So this one, you're solving for x, you move the 1, comes y minus 1 divided by 2. This one, you move the 1, y minus 1, you take a square root. And by the way, this one, class, the one on the right, x equals square root of y minus 1. The one on the left is negative of that. So okay, this part is this. This part would be x equals minus that. And we don't need that, okay? We don't need the left part. And so x of the right comes from the curve, x of the left, it comes from the line. So like so. Let me erase my work. Now, this one is y minus 1 to the power of 1/2. You can do it by the substitution or any method, but I'm going to leave it for you to understand that you can say 1 over 1/2 plus 1. And this one to the power of 1/2 plus 1. Please work on this on your own. I want to make sure that you have no problem with the integration of that. And of course, this is 1/2, then this gives you half of y squared minus y. Going from 1 to 5 now, elementary algebra, you plug in 4 to the power of 3 halves squared of 4 is 2, 2 cubed is 8. 8 times 2, 16 over 3. Okay. Minus 5, so this is 10, 15 halves times 1/2 is 15/4, the negative in front. This one is 0, and this one is a positive 1/4. So you have 16/3 minus 15 over 4 minus 1/4, and that gives you exactly the same answer. This is the second method. I believe the first method was a slightly easier methodology, but it's ultimately up to you. I want you to be exposed to both methods.